and the water supply network, and the UPGRO or the UPRO program as well. And you see the logos and the website addresses of some of the partners on the screen, and also, of course, excellent development, excellentdevelopment.com, the organization that Ian belongs to. The webinar is part of the Water Channel's ongoing thematic focus on multifunctional infrastructure, and I would recommend you to visit www.tv/thewaterchannel/multi, where you'll see examples of water-related infrastructure designed and constructed in a way that it performs several functions. The team also explains the larger idea behind multifunctionality as such, and why it would be good to adopt it as a larger approach to development itself. So, without further ado, I would like to hand it over to our first speaker, Mr. Ian Neal from Excellent Development, who would be talking about sand dams. And following Ian would be Frank van Stekel from Innovative, who will talk about some other examples, including those designed to harvest rainwater. So take it away, Ian. I will expand the presentation right now. And
Great, thank you. Thank you, Abraham, and thank you to everybody who's joining us today. Just to introduce myself, I'm Ian Neal. I'm the Technical and Development Manager from Excellent Development. We do food and water security in dryland Kenya. Today I wanted to talk about the potential of sand dams being used for water harvesting. Later on, Frank is going to look at some other methods that we have in terms of harvesting water. Okay, so I'm just looking for the scroll down. Sorry, Abraham. So today we're going to look at what are sand dams, what is the opportunity and the scale of that opportunity, what are some of the benefits for local people and for road authorities, and later on we'll look at some of the barriers and enablers to wider adoption.
Hi, Ian. This is Abraham.
Hi, Abraham.
Would it be possible for you to come a bit closer to your microphone? Like you did when you practiced.
Okay. Is that any better?
Yes, I think it is.
Okay, and I'm.
Better?
Can you hear me okay if I talk like that loudly?
Yeah, I think we're good now. Yes, we are also getting some feedback that it sounds much better. Okay, please continue.
Okay, fine. So what is a sand dam? This is a photo of a sand dam. It's basically a reinforced rubble stone masonry wall, which is built across a seasonal sandy river. Okay, since ancient times, people have been collecting water from sandy rivers. This technique basically builds on that ancient knowledge and just enhances the sand aquifer. The principle is fairly simple. Basically, sandy sediment is carried down the river, collects behind the dam, and then water, the heavier sand settles behind the dam, and the lighter sediment remains in the flow and is carried over. Okay. Here is another photo of a similar dam. You can see the central spillway, which keeps the flow in the middle of the river. Basically, an average sand dam will collect between 2 and 10,000 cubic meters of water, and that water is recharged every rainy season, and is also recharged from base flow. Okay, research on dams in Kitui in Kenya has shown that up to 10 times the volume of water is stored in the riverbanks and is actually stored in the sand aquifer. Okay.
Excuse me, Ian. Sorry to interrupt again, but would it be possible at all for you to go either closer to your microphone or perhaps speak up a little bit? We are getting some feedback that it's still a bit soft, your sound.
Okay. Apologies to people. Um, can you hear me now?
Yeah.
Yeah.
This. Okay. So yeah, one of the advantages of sand dams is that the water is stored within the sand, and this reduces the risk of contamination, and it reduces the loss from evaporation. It also prevents direct water vectors such as malaria and bilharzia from spreading. Okay. So how do you get the water out of the sand? The simplest option is a simple hole scooped into the sand. If you've got livestock in the area, then people often protect that water source by using acacia or thorns to keep the livestock out. Also, the sand dams are used for irrigation. Okay, so here is a small shallow pond where the inlet for a pump would be put in, and then water is pumped up to the surrounding land. You can also use an infiltration gallery, which is laid on the upside of the dam before the sand is collected. Water filters through the pipe, and then it collects into a shaft. There's a book on the left-hand side called Water from Sand Rivers, which has got further information on your different choices of infiltration gallery and pumps. That's available online. So that's the basic setup, where you've got a pipe laid into the sand, and then water is carried off to an adjacent well, which can be either abstracted by a hand pump or by a mechanical pump. Okay. One of the advantages of sand dams is that they help recharge the aquifer, and they also regenerate vegetation around the both upstream and downstream of the dam. Okay, so that allows you to plant grasses for fodder and also bananas and so forth for additional income, but it also protects the riverbanks from bank erosion. Okay. Some of the advantages of a sand dam. Apologies, people. A very low-cost form of rainwater harvesting, and once provided they're correctly. Sorry, I'm just noticing that you're still having trouble with the sound. I'll try and talk as loudly as possible. Provided they're correctly maintained, constructed and designed, then sand dams can last over 50 years. And that's one of the main advantages that we'll come on to in terms of their use as a road crossing. They increase incomes and food security. They can be incorporated into climate change adaptation and mitigation programs. And as I say, they help recharge the aquifer and conserve biodiversity. They also have application within game reserve roads, whereby elephants can dig down into the sand to get water, and then other game can access the water that way. So where can sand dams be built? There are 4 preconditions that are required for a sand dam. First, it needs to be on an ephemeral or seasonal river with clearly defined riverbanks. Secondly, the riverbed must retain water. So you can tell whether that is the case. If you have the presence of scoop holes, then that is an indication that the riverbed is retaining water. If you've got water in adjacent wells, again, that is a sign that the geology is retaining water, the water table close to the surface. third condition is the riverbed must have sufficient sandy sediment. We test sand by using, let me just show you sorry, the pointer's not working, but on the right hand side there you've got a small portable stack of sieves and the scales, which will then translate to tell you the different grain size within the sediment, and that is an indication of whether you have suitable sandy sediment. The third condition is that the bedrock or an impermeable layer needs to be accessible. You don't want to be digging too deep to reach a suitable foundation. So usually we would dig no more than 3 meters below the riverbed. If we look at where seasonal rivers are found, basically the answer is in dryland regions. Okay, the stars there indicate where there are known examples of sand dams or similar types of structures. Okay, so the biggest concentration of sand dams is in Kenya, but they are found across dryland Africa. In terms of the global population, 35% live in drylands, and it basically sustains 80% of the world's poorest people. It maintains 50% of the world's livestock and 34% of the world's farming land. These are figures from UNDP and UNCCD. Okay, so what is the opportunity? Basically, to combine sand dams with road crossings. So here is an example taken from Makueni County, which is in southeast Kenya. Okay. Apologies, the tracker is not working again. So basically, this provides a year-round source of water, despite the fact that this part of Kenya only has a very short rainy season. Okay, a dam this size, this is about 80 meters wide and 3 meters high above the bedrock. So you can see below the dam, the spillway there is 3 meters above the bedrock. This stream is basically 24 kilometers in length, and just above the dam, it's 30 meters in width. The dam basically supplies 2 schools, 10 water kiosks, and a health clinic, and is pumped at the rate of approximately 50 cubics every day. So that's 50 cubic meters every day. As can be seen, then another advantage of sand dams is that they flatten the riverbed above the dam, which provides an important crossing for livestock and people. Just to give you an indication of their cost, a dam of this size would use in the region of 800 bags of cement. And in this part of Kenya, where cement costs around $9, then the cost of materials for a dam this size is in the region of 10,000 US dollars, of which 60 to 70% consists of cement. Such dams as this can be built using labor-based methods for collecting local materials and mixing by hand. If this labor is paid for, then it basically makes up 40% of the total cost by our estimations, based on day labor rates. In addition to this, then you require skilled labor to support the local community or local authorities in the design and supervision of the construction, and also to manage the overall project. In addition to this, then you will need extra materials for the road surface and also for the infiltration gallery. On this picture here, then the infiltration gallery goes to an off-take well on the left-hand side of the photo, and then is pumped through galvanized iron pipes to the local communities. Okay. In all, these costs compare favorably with borehole costs, but you've got the added advantage that you've got a road crossing, you've got aquifer recharge rather than aquifer depletion, and you've got reduced maintenance costs. So that's basically the opportunity. Yeah, a Sandown River road crossing. What is the scale of the opportunity? Well, there's 5.5 million kilometers of rural roads in sub-Saharan Africa. Of those, 80% are unpaved. They're rural feeder roads, which basically connect local farming communities to the national roads network. Kubinga, who's one of the references found on the website Waterfront Roads, calculated that 59% of these rural roads are in rangelands where cattle watering is central to people's livelihoods, and then 30% is in cultivated farming areas. Okay, so you can see the opportunity of why water in drylands area is particularly important, because these are areas which also suffer from high levels of poverty and food and water insecurity. Okay. Why drylands? Well, of those rural roads, 48% of them are in dryland regions. Okay, so 2.6 million kilometers of lands. Why we're interested in drylands is because these are the type of seasonal rivers that suit sandams and other forms of rainwater harvesting. So I just wanted to look briefly at some of the issues which face rural roads in terms of maintaining and upkeeping the investment. One of the main arguments for improved road crossings is that rural roads are not well maintained. There is not sufficient finance invested into rural roads, and so their maintenance and upkeep. So as a result, basically in order to maintain the investment, you need to invest between 5 and 6% of your expenditure per year in operation and maintenance, and in particular ongoing maintenance as opposed to emergency repair works. Yet when we look at what actually happened in reality, this was based on a study of the Kenya Road Board, which did a survey of the different conditions of road types according to their classification. And low volume rural roads, that's LVRR, 72% of these roads were in poor condition. Okay. Now, when you look at maintaining roads, well, on sorry, people, the tracker's not working very well. So when you look at rural roads, then you'll see that for main roads, the main factors there are around traffic volume, axle weight, and repairing the road surface are critical factors. But in terms of unpaved rural roads, the key factors in road maintenance and their upkeep is drainage, drainage, drainage. And this is particularly true in dryland areas where you have the rainfall is characterized by short, very intense rainfall, which quickly runs off the surrounding land into the watercourses, and you get high flood levels and high sediment loads, which the road infrastructure has to cope with. Okay, this is perfect for sandans, but it's not so good news for unpaved rural roads. In addition, road construction can also lead to erosion, gully formation, and the interception of subsurface flows. So again, when people are constructing roads, they need to be thinking about the impact on water flows and drainage. Next slide I wanted to show you looked at, this was a national taxpayers study of 17 rural roads projects in Kenya, and it found that well over half are either in fair or poor condition. And of the problems that were cited in the road projects, then thanks Hans, sorry about my volume. I'll try and speak even louder. The inadequate drainage and damaged culverts were noted in all but 2 of the projects. Okay. So if we look at a typical culvert road crossing, then this is what it looks like. Okay. And these are some of the problems that are encountered in the operation and maintenance of these. This is why such crossings fail. First of all, you have a lack of poor construction and headwall on the upstream surface of the crossing. Secondly, culverts get blocked with sediment and flotsam. And then another major area is that because the culvert gets blocked, then the floods rise above the level where the road surface is paved, and then that allows the river to spread and to erode away the main road, damaging, completely washing away the culvert or diverting the river around it. Okay. The other alternative to a culvert crossing is a drift crossing. And similarly, if the river flood raises above the level where the paved section of the road finishes, then the road is vulnerable to be washed away. And here we have some pictures which illustrate this. First of all, this is a picture of a culvert crossing with an inadequate and damaged headwall. With time, because there's a lack of fill over the top of the culvert, then those culverts will crack and the road surface will be washed away. And the culverts themselves become blocked. I'm just hearing somebody else. I'm getting lower and lower. I don't know what to do with volume. Sorry, good people. Tell you what. Can people hear me better now? Hopefully they can. Okay, so here is an example of how culverts get blocked. Okay. The third area is culverts cause the river to widen. Because the flow is restricted, and often the river will spread wider, and where the capacity of the culvert is not sufficient, then it gets washed away. So the pointer's not working, but basically on the left-hand side of this photo, that is a repaired culvert because it was washed away initially and had to be replaced. Okay, which is an example of where the capacity of the culvert is not big enough. Okay, switch that arrow off. Okay, this is a nice example. This is again in Makueni County in Kenya. Initially, the riverbank is where you can see the water level at the moment, about 20 meters past where the woman is walking. Okay, but because the culvert didn't have sufficient capacity, and because the road didn't extend up above the flood level high enough, then that whole riverbank got washed away. In repairing it, then they extended the concrete road surface higher. So you can see that in the far distance, that was replaced. The other interesting thing that they did is they blocked in all of those culvert openings. So it now effectively becomes a sand dam. And if you were to be able to see to the left of there, then sand is accumulated behind the dam. They've also planted grasses and so forth to bring the riverbanks back to its original position. Oh, good. I'm glad to hear the sound is getting a bit better. So we are making progress. Here's some other small examples of road drifts which have become small sand dams. Obviously, the opportunity here is to raise these drifts slightly higher so you collect more water and more sand. Just to give you an example, the guy on the right is the Makueni roads engineer, Mr. Benson Masala, and he took me around and showed me the different road crossings that they've been building in recent years. Very well designed. Um, he was saying that just in the last 3 years, between 50 and 100 of these crossings have been constructed. The issue here is that there is no systematic collection of the water which gathers, and people aren't actually designing them in order to collect water. They're merely road crossings. Here's another example from Swaziland. Started off as a road crossing, all the sand is collected behind it, and it effectively becomes a form of sand dam. Okay, so this is what we're suggesting a slightly revised sand dam rural roads crossing would look like. So it's much like a drift, except it's raised up higher, so you collect more sand. And then you've got a spillway on the upstream face, which basically controls where the flood flows go and within the main channel, and don't allow the river to spread and to undercut the dam. Okay, there you can see another schematic. So the central spillway maintains the main channel flow within the river banks, and then the second spillway maintains the annual flood. And then on larger rivers, you may well have a third spillway, which would be for the lifetime or 50-year, 100-year design flood. Okay, that's how we design sand dams in Kenya. The only difference there is that you're incorporating a road within it. And if we can just flag up, we've written a guide, second version of this on practical guide to building sand dams. That's all around the siting of sand dams, the design of them, and the construction. We're not saying this is the only way to do them. This is how ourselves and the NGOs we've worked with in Kenya go about building them. And then another point I wanted to make is the importance of catchment size on where these types of crossings are suitable. So basically, what this is showing is the hydrograph or flow against time of 3 different catchments. The first one is 10 square kilometres, the second one is 1,000 square kilometres in India, and the third one in Australia is 150,000 square kilometres. And what that's showing is on the larger rivers, rivers flow for many days and have several peaks. Now, in those conditions, a culvert or drift is not going to be suitable because the road traffic won't be able to cross for many days. It's drift and sand dam road crossings are only suitable where the rivers are flowing for a few days or weeks a year, no more than that. Okay. The other thing to mention is that basically you only find those types of road crossings on low volume rural roads. If the road justified a larger crossing such as a bridge, it would be a larger road and not a rural road crossing. Okay. And finally, before I hand over to Frank, I just wanted to flag up here that as you go down the catchment, you've got a whole range of different ways that you can harvest water from seasonal river channels. Okay? Check dams, subsurface dams, sand dams, sand river abstraction. So that's basically just an infiltration gallery in a sand river without any dam. Water spreading weirs and spate irrigation. Okay? So it's just to be aware that sand dams are suitable to certain conditions, but not to all different conditions. And it depends on the slope, the rainfall, and the catchment size primarily that determine the conditions you've got. So with that done, Frank and I will come on to looking at some of the barriers to and enablers to enable these technologies to be taken up. But Frank wants other similar technologies of harvesting water from wells. Thank you.
Okay, Ian, thanks a lot, and also thank for all the people who are attending. I think we are close to 40, and like I requested, it's good if we sort of type a few words about each other, which several people have done, so we get to know each other better. Um, Ian, I really find your work very fascinating on the combination between roads and sand dams. We are also working on it, and as part of several activities, but uh, one program that we're very happy to be involved in is funded under UP Grow, which we do with Macquarie University and IDS to look at a lot of opportunities for making better use of roads for water, for groundwater recharge, um, and also for water collection. What I would like to do is to take it from your presentation, Ian, and give a few quick examples of other opportunities. Um, and I'm happy with your last slide. You sort of gave a sort of cross section of a landscape, showing that the different parts of the landscape are different opportunities to make use of roads for water. So there's a list of them: bed stabilizers, floodwater spreading weirs, planning road alignments to avoid erosive floods, but use that drainage water, yeah, which you mentioned, to recharge areas, yeah, making a good use of the culverts, the cross drainage under roads to slow down and direct the runoff to storage and recharge zones, spreading the runoff, yeah, on the downstream side of roads to prevent gullying, because gullying also deplete the soil moisture, and they are a major setback for agricultural productivity usually. Another thing is to look at the foundation of roads. Yeah, often they compact and they block all the subsurface flows through landscape. And then two other ones very obvious is to use the borrow pits, yeah, which are used for building roads as a storage and recharge ponds. And the last one is spring capture, yeah, where roads are made in deep cut. Let me just take you quickly around a small tour of the world, with a bit of emphasis on Ethiopia, where we are implementing the UP Grow program. But first Pakistan, yeah. I saw Allah Baksh among the crowd. I'm very happy. This picture was given to me last week. Spade irrigation. Spade irrigation, you divert short-term floods, yeah, in dry riverbeds for agriculture, for groundwater recharge, for livestock watering, many things. Now the main challenge, yeah, in spade irrigation is how to divert these sort of often violent floods from the riverbeds, particularly if the riverbed is very much rutted and gullied. Yeah. So road crossings, they can serve really as a bed stabilizer. They stabilize the riverbed, yeah, so that, I mean, apart from acting, yeah, as a recharge structure, as you explained, Ian, with all these great examples from sub-Saharan Africa, they also basically stabilize the riverbed. So if people want to make a diversion with soils, with rocks, with brushwood, it's much more easier to do that when the riverbed is not sort of completely, intersected. So that's one thing. Another example that you also gave in the cross section of the landscape is floodwater spreading weirs. Yeah? Then you take it a bit further. You have this little diagram here, basically, yeah, and a road can serve very well as the centerpiece of a floodwater spreading weir. Yeah, so again, in dry riverbeds, you, you create a low obstacle, in this case a road crossing, yeah, and this road crossing then also spreads the flood over a wider area, yeah, where it will recharge wells, where it also will enhance the soil productivity. This picture comes from Niger, and it is courtesy of Heinz Bentner, who has done really very good path-breaking work on this. Um, Moving a bit further, yeah, the impact of roads on soil moisture. I think this is quite fascinating. This is in also still we are in the sort of plain areas, and these are immense plains in South Sudan. Yeah, you know where you know the elevation is close to zero for large stretches of land. So a road is the only thing that affects the runoff, and the runoff comes in huge sheet flows. So what happens in South Sudan is that where you put the cross drainage, it really has a large impact, yeah, on where the water remains for a longer time. Now, if the water remains for a longer time, it has a lot of consequence. Of course, you could say it's good for the groundwater, but in South Sudan also the tradition and the scope is there to burn your vegetation to help the soil regenerate. So in this case, the um, the road impeded the flood, yeah, and as a result, you cannot in time burn, or you can in time burn your vegetation. So this has a huge effect on your pasture lands. Oops, I go a bit too fast. Yeah, cross drainage. Yeah, it's a picture from the research we do in Ethiopia. Cross drainage is so important to sort of make sure where the runoff ends up, and not only where it ends up, but also how it ends up. If you build just a few road crossings, then you'll get very short concentrated floods which will be erosive. If you spread it more thinly, it will be much more easier to infiltrate. This is another thing you can do, yeah, if you have water collected on one side of the road and being routed through the road crossing, then the culvert, then you can also lead it, as you see in this picture, to infiltration trenches. These are the things you see in the first part of the picture. Yeah. So the runoff, which is coming underneath the runoff, is really, immediately sort of converted into recharge. I'm a bit too fast, I think, again. Yeah. Right. Yeah. Interestingly, yeah, as I was going home one day, because this is about 100 meters from my home, I found out that even here in the Netherlands, where I live, something similar is happening. Here they sort of really manipulated the speed of the recharge by making very small culverts underneath the road, and then it gets into a swallow, yeah, and there it slowly infiltrates in this small pit, yeah, on the left side. And another thing, yeah, is the embankment of the roads, yeah. So one is the cross drainage, yeah, where it ends up. How can you channel it to an area where it will cause recharge? The other thing, of course, also, if apart from the culverts, the road embankments often serves as a big impediment, and usually, and I think this is one of the big issues. Road engineers, they are road engineers. They are not sort of multifunctional infrastructure engineers. So often you see, again, this is from Ethiopia, you see water standing on one side of the road and land being dry on the other side of the road. So it creates a problem on both sides. So there's a lot of scope for rethinking, small cross drainage, and not have a sort of massive compacted foundation of the road which impedes the opportunities for recharge and creates waterlogging on the other side. Yeah? What we can also do is to make sure that the runoff from the road, yeah, so this is on the road surface, that it spreads gently, yeah, rather than gushing here and there. And stone bands are very common on slopes, yeah, on flat slopes, but also along roads. They are a great invention. This is from Niger. So the runoff from the roads gradually spreads over the land, yeah, and um, and you know, serves soil moisture and serves also the recharge. Borrow pits. I think that's another opportunity we shouldn't miss. Ian said that we have huge stretches of length, and also we have often many borrow pits along the road. So if you put them in the wrong place, they will serve no use. But if you put them in the right place, they can be a sort of extra storage facility, and particularly in dry areas. I talked with a colleague from the Ministry of Water who had to evaluate a road building project, and people wanted to close down these borrow pits, and the people in the area were adamant. Now they finally had a source of storing water. So this this is something that, you know, now often borrow pits are just borrow pits, but if you can sort of make them a bit better, they can be accessed by livestock, by people irrigating. Again, these pictures from South Sudan. Here the borrow pit is not only filled with runoff, but because the water table is very shallow, it just serves as a seepage pond or dugout pond. This is an example of a borrow pit which is just, you know, the right thing in the wrong place. Well, it's not completely the right thing. It's just a very unregulated borrow pit, yeah, just off stream. If it had been moved just 50 meters downstream, it would have been filled with the runoff from the roads, and it could have served either directly as a storage reservoir, or it could have been used as an infiltration pond. In Yemen, there's very interesting work going on where runoff from the roads, and these roads are low intensity routes because otherwise you have the water quality issue, are used to fill cisterns, yeah, like you see here. This is the last sort of example of sort of maximizing road development for water and for groundwater recharge. And often, if you make roads in mountainous areas, you open up a lot of springs. Yeah, you cut through, you know, small water veins, and you know, you can do two things. If you don't handle this, this will be a constant source of damage to the roads. If you collect them in a reservoir, you can use them for drinking water or for irrigation. And again, one example of trying to maximize the road. Before I hand over to Ian, this is the discussion on barriers and enablers. Ian will take over from that, but I think there's many things we need to do better. And one thing, yeah, is that road design now is monofunctional and non-participatory. Basically, there's no process of sort of taking into account that the road is not something which takes a means of transport from point A to B, yeah, but it is something which affects the whole, you know, socioeconomic setting around the roads. It provides some people access, other people no access. It has a huge impact on your agriculture, on your water availability. So I think one of the big barriers that we need to overcome is that road design, yeah, is now monofunctional and non-participatory, yeah. So I think this is really something that needs to be revisited. The whole road designing process needs to be done differently, yeah, and it needs to. We need to look at the positive and negative impacts of the roads. There's a much larger need in the road design process to engage roadside communities, yeah, for the in the design of the roads, and not only looking at them as a sort of stretch of of tarmac, uh, and also make sure that we have better provision for remedial measures and and processes. So with this, I want to hand over back to Ian. I will answer some of the questions that came in after that, and Ian will continue with explaining the different barriers and enablers that are there. Thank you very much. Ian?
Yeah, hi Ian. Are you still with us? Ian is just working on his microphone, trying to make it sound better. And yeah, he is back. Yeah, Ian.
Don't hear him.
Ian, we can't hear you now.
Can you hear me now?
Yeah,
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 we
yeah,
can.
yeah.
Hey, great. Okay, sorry about that. Apologies for the sound. So I just wanted to run through some of the barriers and enablers of wider adoption of these whole different ranges of techniques for harvesting water from roads. Um, I will talk about some, and then Frank will come on to some of the more political and social issues. The first barrier that I wanted to discuss was the use of standard designs, which, if you understand the history of how engineering institutions spread from the UK and the US to different parts of Africa, you'll be familiar with how a lot of standard designs are based on the experience in the US or UK and are not adapted to drylands hydrology or climate. And so that's one of the issues, is that people are considering technical solutions which weren't designed for Africa necessarily. And there's a need to make sure that they are. So some of the ways you can do this, okay, is just to pilot different innovative water harvesting designs and to record that evidence. Then to document different case studies of water harvesting. Then work with professional engineering and roads institutions and public works authorities to ensure that the standard designs that they have reflect the climate and hydrology where they work. Okay. One of the challenges in working in drylands Africa is the lack of good climate data and hydrology data. So you have to find different ways around that those challenges, which people who have got a familiarity with water harvesting have that experience. And the best road authorities have that experience too. And then incorporate that learning within university courses and professional training so that it gets embedded within the system. Okay. The second key barrier, and I think it's possibly the most important one in my experience, is that politicians and civil servants love to cut ribbons. They love to open things, and I just wish we had more celebrations of infrastructure, which was like the 10-year anniversary of infrastructure, yeah, rather than sorry. So some of the key barriers in terms of funding is the inadequate maintenance budgets. So in order to get around that, have a roads inventory and planned maintenance schedules. Second one is to lobby for adequate funding for maintenance. There's a very interesting fact on this that showed that basically over the last 3 decades, $150 billion has been invested in roads infrastructure, but 50 billion of that has now fallen into disrepair because of inadequate maintenance. It just shows, I can send you some of the details on that if you need to make the arguments. Key area of making the maximum opportunity of these, the better roads and better water harvesting is cost sharing and collaboration between roads, water and agricultural authorities. And then cross-subsidisation from water revenues. So here the opportunity is, as the example I showed in Kenya illustrated, then you're generating income from water sales from water kiosks. Now, is there an opportunity there for some of that funding to be channeled towards the upkeep of the road crossing itself? Okay, then the water harvesting road crossings cost slightly more than the standard design. Not a lot more, and further research is needed to understand those costs better. But in order to make the case for better, for investing in better road river crossings, then again we need to share the costs with water and agricultural authorities and the beneficiary communities. Use of labour-based methods allows beneficiary communities to contribute their labour. By including water harvesting from roads in social protection, disaster risk reduction and climate resilience programs, then you are able to fund investment in these types of technologies through a wider program of work which builds food security and climate resilience. Okay. It's important to document the business case. So the business case basically relies on, because you've got these wider impacts in terms of food security, increase in incomes, increase in improvement in health, and an overall return on investment, then that justifies the added investment in roads infrastructure costs. And the key to that economic argument is by basically considering the whole life of the infrastructure. How much does it cost to not only to build the infrastructure, to operate and maintain it? And if you build infrastructure which is more resilient and lasts better, then the overall cost is reduced. Okay, and then compare investment in water harvesting from roads with alternative methods of investment for water for food in drylands. Finally, there's a lack of data and a lack of transparency in terms of expenditure on roads, and the more there can be independent studies such as the National Taxpayers Alliance in Kenya, looking at different road projects and comparing their value for money, the better we're going to get. We're going to get better economic decisions, basically. And then another barrier to wider adoption is a lack of technical knowledge and implementation capacity. So contractors are inclined to stick with methods that they're used to and familiar with. If new methods are to be trialled and introduced, then there's a need to invest in training and tools to allow people to try different approaches themselves. Okay, so that's developing technical guidance and design tools. It's about organising study visits between roads and water engineers so they can learn from each other, and from one district can learn from another, one country can learn from another. Technical training for the different stakeholders, the local authorities, consultants, roads contractors and so forth. Okay. And then finally from my point of view, Frank's going to come on to, but how do we raise understanding and awareness of this potential? Well, we need to better understand where the different methods and approaches that we've been discussing today are applicable. So what are the different climates and biophysical conditions, the slopes, the catchments, the terrain, the geology that suit different forms of rainwater harvesting? And we've done some work on that, and we're keen to learn, to work with others on that. Sorry. The next area is using that information then to basically map the areas of greatest potential for harvesting water from roads and to develop national plans for prioritized plans for implementation. Okay. Document successful and unsuccessful case studies so that we learn from that experience, and then wider advocacy and influencing amongst a whole range of policymakers. So we're not just talking about roads policymakers, we're talking about water and agriculture and livelihoods policymakers. Okay. And then if I can just, well, this is Frank's slide. So Frank, do you want to take over for me, or are you happy for me to continue? Because I understand what you're saying here.
This one in, yeah.
Okay, let me say, Frank, with your blessing, I will basically make the points that you've got here.
Yeah.
Absolutely, there is need for a better analysis of both the positive and the negative impacts of roads. We mentioned earlier that roads can have a negative impact. They can lead to greater erosion, they can reduce water availability, but we've also seen how they can make many positive benefits as well. This is absolutely critical. In order for people to see the benefits and the potential of harvesting water from roads, then roadside communities must be involved in road design, and involved to as much as possible in decision making and also implementation, so that they have a sense of ownership for the infrastructure and can ensure that the design fits their needs. Simply said, but harder to achieve. Well, it just keeps getting repeated that local communities are not included in the design decisions. Okay, provision for remedial measures and the process of that. So this is basically one of the advantages where you're doing where there has been damage to roads and road river crossings. You have an opportunity there to revise the design so that it can form more of a water harvesting function. So I gave the example where initially there was a road crossing and the culverts were filled in, and then once those culverts were filled in, then the road crossing functioned as a sand dam. But there's similar opportunities there. Another example, if you channel the water away from side ditches or from cross ditches, then the capacity that is required for side ditches is less because they're carrying less water, plus you get the benefits of the water harvesting. Frank, I'll hand back to you on that one, whether you had further points to make on that slide. But for me, then that's just a whistle-stop tour of some of the barriers which are inhibiting us, but also some of the steps that we can take to overcome that. Okay, over to you, Frank.
Yeah, no, Ian, I have nothing to add. I think this is quite a package that we have to work on, but I think the potential is also enormous. And I think, adding the water component to road design could make enormous impact on groundwater recharge, water harvesting, water availability, at very little cost. And if you see the amount of work going on road building these days, yeah, that is much more than the investments in water and water harvesting. So I think this is a huge area to work on, and I think your list of opportunities and barriers is very good. Thank you.
Okay, thanks, Frank. Thanks, Ian. You would have noticed that the slides window has kind of slid and shrunk a little bit. And you now see a window with a bunch of questions. These questions came in through the chat window, and we have copied them and pasted them on in the questions window. So perhaps you could take a look at the questions, starting with Ian probably, and then you could respond to the questions one by one.
Sure. So am I speaking, Abdul?
Yeah.
Okay, absolutely. Yeah. So let me pick up the first question. If I can maybe pick up the sedimentation problem, which was highlighted by Ahmed. Um, so there is a need to ensure that the sediment that collects behind any structure, such as a sand dam or a subsurface dam, is sand and not finer sediment, which will not store or release as much water. And key to that is understanding how much sediment is transported down a particular reach of river. Uh, the factors which influence that are basically the hydrology, how long and how high the river flows for. So sediment transportation is mostly driven by the peak flood, but it's also by catchment size and the duration of the flood. There's further information on this in the technical guide that I pointed to earlier. I hope that it's a complicated topic to just explain quickly, but hopefully that explains some of the quick factors which influence how high the spillway is in order to collect sand and not silt. Possibly the other thing to mention is that the importance of sediment testing. You need to site sand dams on a seasonal sandy river. So obviously, if the river doesn't have sand in it in the first place, it's not going to collect sand. Okay, Frank, can I?
Yeah. No, I think there are two issues which I would like to respond to. I think the first issue concerns the water quality and the effect on public health of open surface ponds, and the second one is the erosion. I think those are very good concerns to raise, and definitely something that needs to be incorporated in the design. I think it's a very interesting discussion. I remember a few years ago, I was in one country and where in many areas you have no other source of water apart from either sand dams or surface storage. Yeah. Because groundwater is not available, or it has a lot of high fluoride contents, etc., etc. So, but I was a bit aghast at that time that people were not considering storage ponds, basically because they don't fit in the MDG criteria, and I think uh, that is something we can't afford. However, the points that are raised, yeah, about pollution by animals, the risk of malaria, is very large. And what I've seen, and this was actually in Ethiopia, is it depends very much on how you manage the pond, how you take water from the pond. Do you use a sand filter? Do you use household water treatment? Um, how you manage the pond itself also affects the risk of malaria, even bilharzia, etc., etc., including the vegetation. So I think that's a huge scope of work, and I think that particularly in the drinking water sector, we need to, in the most difficult and most deprived areas, it would be very, very useful to have a better handle where there's no other source apart from these sources to take care of these effects. So these points are very, very valid and very well taken. Um, I mentioned the Eastern Calcutta wetlands, where I was just 2 weeks ago. It was amazing what can be done by some ecological engineering. This is an unbelievable place. If you're ever there, I really would encourage you to go there, because this is the sewage water from Calcutta, and it enters in this huge, very shallow wetland. And because the way the people, the fishermen in this case, manage the inlet of the sewage water into this surface water pond, and also the vegetation, how that is managed. On one side you find yourself standing next to a, filthy sewer, and then you walk 30 meters and you're on the border of this, very productive wetlands with small wells being developed in the bank of the wetland to serve water sources. So there's a lot of scope for doing things very well. I think the other one is sedimentation. Yeah, I think it was Peter who raised that issue. Yeah, I think that is really important, and I think often that's where things go wrong. Also, you see that with road culverts, for instance. Once the road is finished, nobody takes care where the water goes, and this is what we found in the UP Grow research in in Ethiopia. This is often sort of creating havoc. It's destroying lands, destroying wells. It's scouring out productive land and depleting the soil moisture. I think also we can turn that around. And I mentioned Heinz Bender. Um, he has written a very useful French document on using roads basically to counter erosion. So if we do it wrong, roads will accelerate erosion. But if we do it right, basically, the road is like a huge band across the landscape, which you can also use for controlling the erosion, which is not caused by the road, but just the natural erosion caused by other sources. Soon we will announce it also through the Water Channel website called Water from Roads, and we're trying to put as many documents there. And I also encourage you, if you have anything you want to share, this is all open access. And I think we're a small but very important community of practice, and I think we need to, hang on to each other and try to make use of the opportunities that Ian has outlined.
Okay, we have a few more questions now. Uh, Perhaps I could draw your attention to Diego's question, uh, the one in which he says that Ian specified riverbed stability as a requirement for sand dam construction. But doesn't the sand dam stabilize the riverbed itself?
Okay, thank you, Diego. My answer to that would be that the dam requires a stable foundation, which ideally is bedrock in the riverbed, but it could be an impermeable clay layer. What you don't want is, or what you need to avoid is, if the dam is placed on just river sediments, then water can tube underneath the dam and undermine it. You'll both lose water under the base of the dam, plus you'll undermine its stability. So that's what I was meaning in terms of the requirement for a stable foundation. Um, yeah. So.
Can I add a little bit to that? Because I gave the example of spade irrigation. So there, what the dam does, or the road does, it creates the stability upstream of the riverbed. So that's different from what Ian is saying. Maybe that's where the confusion came in a little bit. But if you in spade rivers, if you make a good road, yeah, which of course should not wash away, yeah, road crossing through the riverbed, it has a enormous good impact on making sure the river is not sort of scouring out, which makes it difficult for people to divert water from it.
Okay, the next question is from Joseph de Trincheria. He says, how do you make sure that when the spillway is raised, only sand and not silt materials will be stored upstream of the wall? How is it possible to prevent this, taking into account different biophysical factors?
Okay, thanks. Shall I start off? In the Sandam manual that we're about to release, and I'm happy to send everybody a review copy, we go into this in quite a bit of detail. Basically, the things to look at, first of all, you need to ensure that your riverbed contains sandy sediment in the first place. A dam will only capture the same type of sediment that it already had in the river to start with. If you have silt in your river, you will have a silt dam and not a sand dam. Second issue is that the central spillway height needs to be at the level such that it fills within a reasonable time. Some advise that it fills within one rainy season. Our experience within Kenya is that that's not necessary, that you can, provided it fills within, let me say, around 3 seasons, 3 years, then the motion of the river coming down the watercourse is sufficient to churn up the sediment and chuck over the finest silty sediment that collects on the surface. That's been our experience. I've done the testing on the sediment. There are no finer silt lenses in the dams that we've constructed. Now, where you're working in a new area, you don't know how much sediment transport there is. The key factors to look at are the catchment size. Basically, the bigger the catchment, the more water you have coming down it, the more sediment you're going to have transported, the quicker the dam will mature. So this problem of siltation is most likely to be a problem on smaller catchments. The second issue is the nature of the hydrology. How much water do you have coming down there? So that you're looking at runoff, you're looking at rainfall, and so forth, is slopes. So where you've got less slope, where you've got less rainfall, then you're going to have less sediment transport. Basically, once you've built several dams within an area, then you build up a picture of how much sediment transport you have in a particular basin or area. But initially, those are the factors to be looking at, and I really welcome people's comments on that, because it's been it is an area of controversy on SANDAMs. But I believe those are the factors you need to look at: catchment, rainfall, slope. Okay. Thanks.
Okay, thanks, Ian. The next question is from Ahmed.
Yeah. I can also take that because I'm quite familiar with Egypt, Ahmed. Your question was, you know, to what extent can sand dams be used to, maybe Ian can complement, can alleviate the upcoming water crisis in Egypt, and particularly addressing the huge evaporation from Lake Nasser. Now, I think, of course, the evaporation from Lake Nasser is beyond what sand dams can do. But I think there's a basic principle. I remember a couple of years ago, maybe 7, 8 years ago, there was a lot of debate. There's very little storage, per capita in Africa compared to the USA or Spain, for instance. But I think that is only surface storage, and I think often if we, what like sand dams are doing, but also a lot of other techniques, or Cecilia is suggesting also, if you look at the problems that happened in Sardinia recently, I think there's a large number of things to do, and it can be sand dams, that can be the different clever ways of road design, that can also be things which are more sort of watershed related, where basically you don't store surface water in a huge reservoir, but you store water as groundwater, and that has many examples, many advantages. A, the disease factor. B, the evaporation is much less. C, if you have a lot of moisture in your landscape, then, for instance, your natural fertilization processes, because there's more nitrogen fixation, is taking place within the soil. This all gets better. The microclimate is improved. So I think, in general, where it's possible and where appropriate for that particular environment, it's really important to look at water storage, in the soil profile and as a shallow groundwater. I don't think immediately Lake Nasser's evaporation can be resolved, but what always surprised me, if you talk about Egypt, for instance, the Nile is a really interesting system, because all water which is lost along the Nile by inefficient irrigation, for instance, it stays within that very wet water buffer along the banks of the river. So you can use it, reuse it, reuse it, reuse it. So it's very simple. At one stage in Egypt, water was being diverted to the West Delta Canal, but that water which you lose will be very hard to retrieve, because you have massive, sand layers. So whatever water seeps away, it's hard to get it back. It's a dry buffer. So I think in general, the work that Ian is doing and you try to do as well is very much on developing these water buffers at the right place with the right techniques.
I couldn't agree more, Frank. Basically, um, yeah, when you're looking at a country like Egypt with very low slopes, then you need to be looking at a range of technologies, um, water spreading weirs, spate irrigation.
Yeah.
Um, really, sand dams are not going to be appropriate for large sections of Egypt, but we can look at it in greater detail if you're thinking of a particular location.
Thank you so much, Ian.
Thank you.
The next question is from Laura from Uniwater Education. If you allow animals open access to water in border pits, that one.
Yeah, I think I already addressed that. I think for sure you need to, where you can do, you can make a special troughs. That's a very good idea. I've seen that in South Sudan. Only there's also cost factor involved. Um, so I think what many people said, it's a matter of balancing different options. You can also treat the water quality while you take it out of the river. What you see in Ethiopia, where they can, they make separate ponds for livestock and separate ponds for human beings. Definitely, it's an issue, and which should not be ignored. And there's always a sort of range of options, either on the treatment side or on the source side, that you can do.
Yeah, I'd agree with that. Separation is critical.
Yeah.
So, water for people,
Okay.
water for plants.
Next up, we have Allah Bugs from Pakistan, who's asking, the soil is usually taken from the surrounding of the road, which de-shapes the natural soil. So it should always be carried from the places where creek water flows.
Yeah.
I think you can easily. I think that is. It's true that if you just make indiscriminate, borrow pits, it creates a lot of erosion. It can create stagnant ponds of water, which you can't access. So I would think make the borrow pits part of the whole landscaping. Yeah, the sort of and don't just use them again as borrow pits. Just look at how you can use them, place them in the right place. I don't think you should not allow borrow pits or take the sand from large distance because that can be very costly. Um, uh, but I think make sure that they are properly made so that they can be filled with water. They can be accessed. You have proper arrangement, maybe double ponds for livestock as well. So I think, I mean, borrow pits for me are a huge, huge opportunity, yeah, to create more water storage at zero cost.
Yep, agree with that.
Mhm.
Good.
Rose asks, would it be possible to create reed beds on the dam edge to both stabilize and filter?
Okay.
Yeah, again, I think yeah, Ian, go ahead. Yeah, we addressed that a little bit. I mean, I think the examples where the sort of climate allows that the vegetation, particularly in a shallow pond, yeah, can improve the water quality a lot. Um, so I gave the example of the Calcutta Eastern Wetlands, which is doing just that.
Okay. I think we can maybe answer this as well as the next question around formal testing of water sources. Um, basically, the sand is where the water is filtering through the sand, then the sand is basically acting like a large sand filter, slow sand filter. So we've done some testing on scoop holes and on water which is abstracted through infiltration galleries. It won't surprise you that the water from the scoop holes, it depended, but a lot of those sources were contaminated. None of the water drawn through infiltration galleries was contaminated, i.e. we were testing for basically E. coli and coliforms. What I would say is further testing is required. So we haven't done enough testing, but the initial results show that the improved sources, where it's taken through an infiltration gallery, the water is of a high standard of quality because it's basically filtered through sand. And yes, reed beds are very good for stabilising the riverbanks because you can imagine a dam causes the riverbed to rise and therefore to spread. So by planting reeds where the original riverbanks are, it brings the river back to its original position, which is crucial.
Yeah.
But in terms of water quality, the sand filters the water. Okay.
Yeah. Rose asks another question. Can fine filter nets be used over the culverts? Water through debris out.
I think Ian is the specialist here, but I think that is
Yeah, sure.
difficult
So,
because I think that will fill the culvert with sediment,
correct.
and it's probably the best way to screw up the culvert.
Yeah.
So I don't think that's.
The photos where it's showing where flotsam, debris which is carried down by the river blocking up the culverts, that would be doing
Yeah.
the same job as putting nets over the culverts. So
Yeah.
the example we showed where those culverts were filled in and effectively acted like a sand dam, shows you what would happen if you blocked up the culverts. Basically, provided that the road surface extends sufficiently high up the banks so that it can accommodate the flood flow, then that structure will be stable. But as soon as the flood overtops the road crossing, then it will get eroded away. So anything which blocks up culverts is to be avoided if the intention is to have culverts. But the whole argument I'm making is that by filling in those culverts, you are intentionally making a sand dam.
Yeah. Yeah.
Rose also wants to know how much damage is done by wind erosion.
None really. So silt collects at the top of the river sediment behind the dam. As it dries out, then wind can carry that finer sediment away. So to the extent that there is wind erosion of the river sediment that collects behind the dam, that is beneficial.
Yeah.
Beyond that, the impact of wind erosion on farming in general, that's not really influenced one way or another by road structures or sand dams, other than the ability to plant trees because you have a water source all year round to break up the wind.
I agree.
And create shade. But,
Yeah.
no,
Yeah.
wind erosion doesn't appear to me as a big problem.
Yeah. I agree.
Sure.
The next question highlighted in red
Yeah.
is from Mantech Incorporated, and he asked if there is any formal testing done on these water sources.
So, as I said, formal, no. As in independent water authorities doing their own independent testing, I'm not aware of any. We have done our own water quality testing, but it's been limited, and it was the results that I explained, that where water is taken through an infiltration gallery, the results are promising. We didn't find any results with positive E. coli. It was all zero. But samples taken from scoop holes, some were free of coliform, but most did have some coliform. The question you have to ask yourself around water quality is the whole cycle of water, where it's being stored, the possibility of contamination at home, and what is the alternative water source. If they weren't using a sand dam or a different water source, what would they be using instead? And how does that compare in terms of water quality?
But as I say, the initial results are that water from an infiltration gallery is clean, but further tests are required. And if anybody would like to fund that type of research, I know lots of Kenyan NGOs that will be willing and able to undertake that.
Mhm. Yeah, I fully agree. I think also that again, it's a trade-off, because if you look at the MDG criteria, then we would just sort of base our investments on that, then we would miss a lot of opportunities to improve the situation, the drinking water situation of people. And but I think in general, there's a sort of trade-off to be made to water availability and water quality. And it's what Ian says also as well. I mean, I've worked in Pakistan, and then even if water comes out of the tap relatively clean, then it is contaminated further down the chain. So it's an issue where I think it's not sort of only testing the water quality at source and saying this is good and this is bad. Sometimes if it doesn't fit the criteria, still is better than nothing. And sometimes when it's good, it gets contaminated further down the line. So
Correct. Agree with that.
We are about half an hour beyond the expected duration of the webinar. But if it's good with Frank and Ian, there's still a couple more questions. And okay, great. So we'll go ahead and take a look at them. So the next one is from Alessandro, and it's the one in red.
Yeah.
It's the long question that talks about how it is possible to keep the costs low and provide the right protection to the structure
Yeah.
in remote and poor regions.
Okay. Well, to me, this is part of the exciting opportunity. You already
yeah,
have money being invested in these road
yeah,
river crossings. By slight adaptation, then you're
yeah,
making that investment more resilient because, in our experience, well designed sand dams, and I would include within that well designed drifts, are very robust structures, but it's undeniable that poorly designed culverts are not. So you've got an opportunity to save money there. You've got a great opportunity for creating a water source at the same time. So you're getting a double win there. And because they're relatively low maintenance structures, then that's why they are suited to poorly served and remote areas. So it's not, I think the funding is there. There's money being invested in roads. There's money being invested in climate resilience and agriculture and
mhm,
livestock resilience. The question is making sure that the solutions are all tied together. Frank made a great point about
yeah. No, I
being
think
on the
even Ian
side.
is. Yeah,
Yeah,
I
go on,
think
sorry.
Ian is even sorry. I think it's even a triple win, because most of the damage to roads are caused by water. So even for people who have a sort of single focus on water, on roads, yeah, taking better
Yeah,
care on the water management around the roads would also reduce the maintenance cost and the damage to roads. And so, it's at probably not even a little extra cost. It's just a little extra effort to do things better.
yeah. Win, win, win on that one.
Win, win, win. Yes.
Okay,
And landscape
Jonathan,
protection is great.
can the sand
Mhm.
of a sand dam become covered with vegetation, and is it a problem? And the question extends, can a sand dam become silted? And what can you do if it does?
Right. If I could answer that one. So, the presence of vegetation in the riverbed before you build a sand dam, that is one of the indicators that will tell you that you don't have a lot of velocity coming down that river channel, and therefore you don't have a lot of sediment transport. So you should be careful that in those conditions that uh, when you're piloting a sand dam, that you do so in an incremental way. Because, like I say, if you've got vegetation in the riverbed, that's showing you that you don't have a lot of sand to fill that dam. It doesn't mean you can't build a sand dam. It means you have to build that sand dam in stages. Um, yeah, so But
Yeah.
if in most settings where sand dams are suited, you would not get vegetation growing in the riverbed. The whole siltation question, I think I answered that before, but it basically comes down to is most likely to be a problem in small catchments where you don't have a lot of sediment transport. Uh,
Yeah.
so if you're piloting the technology for the first time, choose larger rivers and choose larger catchments, and then learn from that experience and work backwards.
Excellent.
How about gabions instead of masonry walls for sand dams? Peter de Lang asks.
Great question, Peter. I would love to try that. You're not the first person to suggest that. My questions would be around, are gabions actually cheaper than rubble masonry? And how much water would you be losing because water can filter through the gabions? Now that might not be a huge problem, and by raising the riverbed, that will be sufficient
Hmm.
to create more water locally.
Yeah. I think though with gabions you would not be able to use them as a road, isn't it? If you would have a gabion and sand dam, that sort of dual purpose as a road might be more difficult.
Yeah, you're quite right, Frank. So the
Uh,
use of gabions would quite possibly suit an alternative to just sand dams, but it's not an obvious alternative to a road crossing.
Yeah.
okay, Peter just typed into the chat window that coarse sand from sand dams can be used often as building sand for concrete structures.
Yeah.
I think that is really a very good one actually. Um, I think one of the issues I talked earlier about water buffers, is that a natural river is very important, yeah, for two things basically. If you have a flood, the flood gets absorbed somehow in the, in the bed load of the river, in the sand, in the, in the gravel, yeah, and and then and so the flood damage is limited, and that flood sort of recharges the aquifers, because particularly in dry areas, but even in wet areas, a lot of the base flow of a river comes from groundwater, which is of course was probably at one stage was partly supplied from the river water during high flows. So if you take out the sand and the gravel from a riverbed, yeah, then you delink that process. And I think often, I mean, in Kitui, I've seen rivers which are sort of dead. They are sort of excavated to the bone, yeah,
Yeah.
because people needed the building sand. And I think this is what you see in many parts of the world where a lot of construction is going on. The easiest place to take your gravel and sand is the riverbeds. But in doing so, you basically reduce the capacity of rivers to buffer the floods and to recharge the groundwater. Plus, you create a larger gradient, so more sort of the water from the aquifers surrounding the river starts bleeding into the river. So I think this is a very important issue, and uh, I think Ian also shared at one stage the work of Erik Nielsen Pedersen. He's also been saying that, well, if we do it right, we can also use sand dams, yeah, to harvest coarse sand, but we should not scoop holes in them. We should just sort of skim off the top layer. Ian, you might know more about this. I think in general, this whole issue of where do we take the sand, yeah, for the construction of cities is very important, because you can also, of course, use borrow pits, not necessarily the riverbed, and then have those borrow pits that you use for taking out the sand if you have a good deposit. I mean, this is happening a lot. The town where I live in the Netherlands, the recreational areas were basically they're large ponds and small lakes which were created because people needed the building material, and they're fine. Yeah. So I think again it's a sort of trying to combine things rather than delink things, which is very important.
I would echo that. I think you have to be very careful in harvesting sand from sand dams. So small scale, where it's small. Well, basically, the approach that we recommend is that the structures are registered and the water rights are registered with a local community group, and they manage the abstraction of water and sand, and that avoids any bulk abstraction of water or sand. And it's a major problem in the areas around, well, any road which is close to Nairobi, you'll see the trucks going backwards
Yeah.
and forwards, full of sand. And this is why NEMA, the environmental agency in Kenya, a few years back introduced regulations to control this. Unfortunately, those regulations are not well enforced, so it is a major problem.
Yeah.
So small scale harvesting of sand, no problem. Large scale harvesting, big problem.
Yeah.
Okay, with that, I think we might have reached the end of this fairly intense session. Thank you so much, Frank. Thanks, Ian, for your very informative presentations. But I would also like to thank the people who participated, all the attendees, because as you would have noticed, we have a fairly long list of questions and answers. And that was really great. The interaction was really great. If you have any further questions for the speakers, you could send them to info@thewaterchannel.tv. And I would also like to tell you that a recording of the session would be available on www.thewaterchannel.tv/webinar. I have posted the links and in the chat window, so you can just click on them and you'll go right there to that page. So, okay, thanks again, everyone, and hope to see you next time at the next webinar. Thank you.
Okay, welcome.